LinkedIn is pushing, all the social media platforms currently are pushing live events. So it's a fantastic way to maximize the audience. And we should be live right now on LinkedIn. And let's get started. Kimberley, it's good to see you. How are you doing today?
I'm good. I'm excited that it's Friday. How about yourself, Christian?
Oh, I'm very happy that it's Friday. It was a fantastic day here in Vienna. Where are you in the United States?
I'm on the coast in California.
That's beautiful. Which part of the coast? Is it more to the north or to the south?
More to the south, yeah.
Yeah, the last year I was in San Diego in June. It's gorgeous. Really
yeah,
nice
is
region.
so beautiful. Yeah, it's a little stormy today, but
yeah.
We'll see what happens this weekend.
We don't have, unfortunately, we don't have an ocean here in Austria. I'm in Austria, in Vienna, and let's get right into the topic, climate change. Every morning I go for a run, and I remember basically when I grew up in the Alps, so we had really hard winters back in the 70s, 80s of the last century. It was in Celsius, minus 20 to minus 30 degrees most of the time, and winter ended very abruptly at the end of April, beginning of May. Then I moved to Graz. It was a little bit more south in Austria, Mediterranean climate. So the weather was much better during the year, and spring actually started in March. And after I finished my career at the university, it was around the year 2000, I moved to the capital of Austria, Vienna. It's a little bit more north. And I always remembered Vienna, since I go running every morning, as a lot of humidity in February, March. It was gray, and it was not really a nice spring weather that I was used to have in Graz already early March. And today I was on a run this morning. It's mid-February, and we had about 15 degrees today. So it was pretty warm. It was a nice spring weather. It was the weather I like when I was a student. And my first question to you is this just coincidence? Is it a little bit warmer now in Vienna, and next year it will be different? Or can we attribute this development to the big picture of climate change?
Well, I definitely wouldn't attribute anything that you just described to climate change. You're describing weather in different locations. So what's happening with climate change is that we're seeing non-linear changes that are looking different in different locations. Some areas may be drier and hotter, some areas may be wetter overall, but generally warmer. But that doesn't necessarily mean that the weather is all going to change in the same way. So based on what you described, I'm not really sure that I could attribute that to anything besides local weather.
Yeah, where do we stand in climate change, generally speaking? What's the status currently?
Give me a little bit more about what you mean by that. What do you mean, what's the status? Like, what's the ppm of CO2, or what are you looking for?
I'm looking for just getting an overview about the topic of climate change. So when you open the internet, currently it's a little bit, there are some messages that I read that are confusing to me. Some attribute climate change to it's just normal. It's just, like I said, weather. It's just a little bit warmer sometimes. And some say that we have a severe problem, that the temperature, generally speaking, in the next 100 years will go up. And it's really risky for humanity. What I would like to use this recording is get a little bit more insight and a better overview what's true, what's real in climate change, and what is just superstitious stories that are currently spreading on the internet. And I'm hoping that you, as an expert in climate change, can bring a little bit more clarity to me and my audience.
Sure. Okay, so we'll just start right at the beginning then. So the planet is one system. Even though it feels like it's really far away between you and me right now, we're actually connected through a lot of different things. But what we're going to be talking about right now is the atmosphere. So there's a couple different layers that protect us from space, and that also encompasses the planet and is able to hold things. So when we release carbon, when we release water vapor into the atmosphere, some of it is absorbed in different ways, and some of it stays in the atmosphere. So basically what's happening with climate change is what we're calling the greenhouse effect. And this has been well known by Western science since the early 1800s. that when you put more stuff in the atmosphere, be it water vapor, be it nitrous oxide, be it any form of carbon, then it traps more heat. So the sun that comes into the atmosphere doesn't come out. And there's a little bit more radiation, radiative forcing that stays and warms the planet. Now, the reason that we call it climate change is not because it's going to be getting hot and dry everywhere. That is not correct. Everything is going to be regionally different, just like we're seeing right now. So we just had floods in California, and right before that, we were having a drought in California. Both of those are due to this extreme that we are starting to look at. So whereas our climate used to be in the middle of the bell curve, kind of a normal Holocene climate where we all evolved and it's nice on some days and it's icky on some days, now we're seeing extremes across the scale. So we may have some years of severe drought and then a punctuated storm. And that's just simply because the atmosphere is able to hold more heat, it's able to hold more water, and that's changing the circulation of the winds, it's changing the circulation of the ocean, it's causing the sea ice to melt on both poles, which is then further changing the way that the atmosphere and water circulates. So there's a lot of dynamics that are changing, and they're changing faster than we've ever seen in Earth's history. We're literally talking about thousands of years versus not even 100 years. So we're playing a very dangerous game as humans right now, functionally terraforming the Earth to see what will happen if we introduce all of these new and weird dynamics. And there's a lot of concern about what that can do to the stability of the system. We're already losing biodiversity on a huge scale, what we're calling the sixth mass extinction, which means that plants and animals are dying faster than we've seen in many years. And so what that is causing across scales is instability. We're not really sure. It's much harder to predict the weather. It's much harder to predict this complete collapse of ecosystems that we rely on and we live with.
Well, an unpredictable weather I could live with. If we destroy our planet, it's a little bit a different story. What are the root causes of this climate change? Where does it come from?
So that's what I was describing. It's the release of carbon, water vapor, other gases into the atmosphere by humans. So if you think about we're kind of treating the atmosphere like it's a garbage dump. So we're just kind of throwing everything willy-nilly. There's no real strong regulations saying, hey, you can't put carbon in the atmosphere. And so that's where it's all going. And it's some of it cycling, like I said, but some of it's staying in the atmosphere.
So it's basically driving with cars, fossil fuel, for example. If you understand you right, it's one of the root causes.
That's one example. Driving with cars is not the main cause of climate change, no, but that
What's
is one example
cause?
of the release of carbon.
What's the main cause?
There's a number of different industrial sources. And we see with our new tool called Emit, which is on the space station, that there's a lot of methane leaks all over the planet, whether it's from oil and gas drilling, from oil and gas use, from garbage dumps. And methane has the ability to warm the atmosphere at a much higher rate than CO2. So there's a lot of different ways that carbon gets into the atmosphere, but it's at the individual scale. It's really at the very large scale, oil and gas industry, corporations. Those are the main folks who are causing this change.
You mentioned measurement from the space station. Can you explain a little bit more in detail what's this new tool is doing? It's on the ISS, I think.
Yeah, so it's called Emit, and it's measuring all sorts of different types of, let's say, dust, but also the land surface and the way that the land surface structure is. But one of the things that it's able to do that was not the main service, but it's able to do is identify methane. So it's identifying where methane is coming out of different locations.
And that's a great thing to have. Then it is 100% accurate, I guess.
Nothing in the world is 100% accurate. No, that's impossible.
As accurate as it can be. What is within our control? I read sometimes on the internet that there are these large cycles that the climate changes all the time in the history of the planet. How much is man-made and how much truth is in this story that also some general changes in the climate that occur all the time on this planet play a little bit of a role?
Christian, I'm happy to send you some links that you can share with the folks who are listening. This is an extremely well-known fact, and it's been extremely well disproven that the climate change that is meant to be happening is what's happening. We are very clear that this is human-driven climate change. What I had just mentioned to you about the timescale of thousands of years versus 100 years, we have visualizations on different NASA platforms to help people understand this. But it's really indisputable. I know there's some voices who are loud about whether or not this is human driven, but it's really not even worth, in my opinion, discussing, because we can discuss all day whether or not gravity is real, but that doesn't change reality.
That's a good example. So we can just say that climate change is definitely human-made, and we can do things against it. Which measures do you recommend to normal people? So if we want to do something, like myself, for example, if I want to do something against climate change, what can I do?
So I always say the most important thing to do if you're interested in addressing climate change is write to your representatives. There are a lot of people taking direct action, which is a tactic that humans have used in the past to success. There are also other crises happening, like I mentioned, the biodiversity crisis that works in tandem and is potentially a direct result of some of these climate changes, depending on where we're talking about. And there are things that people can do on an individual level for those, whether it's taking your garden and replanting it from grass and turning it into something with native species, giving space for pollinators, turning off lights outside at night, choosing to drive less. There's lots of different things to make the ecosystem where you live, the animals and plants where you live, more happy and be in better relationships with them. But as far as the large scale dumping of carbon into the atmosphere, that is something that is going to be important for people to take care of on a very large level, because it is fossil fuel and industries that are driving it. And because of that, we really need to get our political willpower involved.
Yeah, that's a good advice. I mean, I learned this year or last year, in 2023 already, that I always thought that the electricity that I consume here in Austria, in Vienna, is basically green. So I grew up with the story that most of the electricity that we produce in this country is derived from rivers, and it's basically as natural as it can be, and it doesn't harm the environment. When, unfortunately, the war started between Russia and Ukraine, I learned that it's a little bit different, that the majority of the electricity and the heat that I consume needs Russian gas to be produced. And I think gas is not really the best solution for producing electricity. Am I right in that assumption? When we talk about climate change.
I'm not an expert in how electricity produced, but I know that there are options for producing electricity using solar, wind, hydrologic forcing, like you mentioned. So I know there are a lot of good other options besides oil and coal. One way to think about it is that we did an amazing job advancing technologically using oil and gas and coal, but we have come to a point technologically where we can advance past that. We're now smarter as a species, we have more tools as a species, and we don't need to use these old tools. What we can do is we can move forward and create a more healthy, living, natural planet. And it seems like we should probably go ahead and do that and keep following the most interesting and technologically advanced thread.
I couldn't agree more. Let's talk a little bit about your background. When did you become interested in the topic of climate change?
I guess it wasn't so much an interest for me as kind of a need. So I've always been very, very dedicated to the planet and to the earth around me ever since I was a very, very small child. It was always my favorite place to be outdoors, and I would stay outdoors as long as possible every single day. And so obviously, as someone who really loves the planet, it's important to me for it to stay just as safe and healthy as possible. And so this is such a huge crisis. It's an existential crisis. It's a human crisis like we've never seen, never before in human history. And so it's very important to me to be part of the solution, or, at least having conversations about what the solution could be.
Yeah, that's a good point. You're a climate scientist at NASA's Jet Propulsion Lab. How did you become that?
I interviewed for it. So I have a bunch of different degrees. My last degree was a Ph.D. in Earth and Climate Science. And I did a bunch of research all over the world in the high altitude and high latitude places. And so when a job opened up at JPL looking for someone who could do Arctic science, it seemed like a good fit. So I went ahead and tried for it and was able to move into that group. And then since then, I've done a bunch of different things, but all in service of understanding the planet better, helping people understand why, all the reasons to love it, and then ideally protecting it.
Yeah, that's a good point. I learned it from my grandparents. Protecting the planet is one of the most important things, and keeping the environment clean. You mentioned your PhD work at the University of Maine. If I researched it right, it was on the health assessment of glacial meltwater pollution. Can you tell us a little bit more about your findings in your PhD work?
Of course. So that was my dissertation. And for folks who don't know, there's a variety of different components that go into your PhD. You take classes, right? Just like you have at every single level. And that's a huge diversity of topics. And then you need to choose a specific thing to research and study, ideally something that hasn't been done before, or that you are really contributing to the state of the science. And then you do a bunch of research on that, and then you write at least 3 papers, peer-reviewed journal article papers or chapters, and then you put that out for everyone to see and gain the knowledge from. So that is what I did for these 3 papers for 3 chapters. And what I was looking at is whether DDT, which is an old what is it called? Pesticide, sorry, which is an old pesticide that we used to use that's very dangerous, and also hexachlorohexene, which is a pesticide that's still being used, can be found in glaciers very, very far away from where the pesticides were used. And whether when the glaciers melt and those chemicals come out, it could hurt the people who live downstream, and whether it could hurt the animals that live downstream. And we found that in some cases, when there are downstream people who eat a lot of local fish, it could be an increased risk for them for cancer if they're eating this local fish over their lifetime that have been exposed to DDT. There's also potentially secondary impacts to the ecosystem, right? It's not good for fish to absorb DDT through their gills and then keep it in their bodies. And it's not good for the other animals who eat fish. It's not good for the plants around. So it's just another reminder that everything that we put into the atmosphere stays in the atmosphere and circulates around. And so when we use DDT in Louisiana, it may not stay in Louisiana. It may end up in the Arctic or the Antarctic.
So it's basically the same when I drive with my car. It's a 20-year-old diesel car. So it's basically, it doesn't stay where I'm driving. It just travels through the atmosphere to other places. And this is with every gas that we put into the atmosphere.
It's similar, and it depends on the type of gas. It depends on the weight of the gas, the properties of the gas, where the gas goes. But in this case, the 2 that I described, DDT and hexachlorohexene, they have specific properties that make them really go towards the snow and ice in the cold areas and then stay there.
And are released later on.
They're not necessarily released. It's just that they don't change state. So they landed on the glacier, they got and trained in the glacier, they became part of the glacier, and then they melt out of the glacier. They're just staying the same the whole time, but we're allowing them to move into different places.
Building on what you just described, I also read on the internet that you are doing or did the Arctic Methane Project at the JPL. Can you tell me a little bit more about this project?
Sure. So the Arctic Methane Challenge is a combined effort between NASA and the European Space Agency. And it's basically collaborating with a bunch of experts from America and Europe to try to understand what's going on in the Arctic, how it's changing across time scales and location scales, and whether or not we have the opportunity to forecast methane and carbon that could be coming out of the permafrost. So permafrost is soil that's frozen for 2 years or more, and it covers 24% of the land surface. So almost a quarter of the land surface. It's a huge amount of land. And it's basically a bunch of dead stuff. It's detritus over years and years and years and years built up. And so when it thaws, because it's getting warmer in the Arctic, it's getting 4 times warmer in the Arctic than anywhere else on the planet. There's little microbes that eat all of the dead stuff. Just like in your tummy when you eat food, you've got microbes that digest it. And so when there's microbes that eat the dead stuff, they release methane and other forms of carbon gas into the atmosphere. So if this process were to speed up and happen really quickly, it would be a huge amount of methane released into the atmosphere, which, as we've discussed, is a really serious greenhouse gas. So it means that there'd be a big warming that could potentially happen.
So we have basically a double effect when we produce in the Western society more greenhouse gases. To just summarize that, we heat up the planet, and this accelerates the melting of the ice and permafrost in the Arctic and Antarctica, which then accelerates the effect of warming the planet. Is this the right understanding?
Yes, that's the concern, is that it could accelerate the warming of the planet. And the challenge is that right now humans are releasing the most carbon. But if we make the ecosystem so unstable that ecosystems start releasing carbon, you may have seen a report that when they were burning huge parts of the Amazon, that it was releasing carbon, not taking carbon in. And if that happens, then we just have a ton of different places releasing carbon and very few places taking it up. And then that's where we start having very, very serious problems.
It's when do we reach the point of no return then? This is
we're not sure. There have been a number of papers that have come out very recently about tipping points, which is what we call when the ecosystems functionally switch to a new state or collapse or start releasing carbon, whatever it looks like for that particular ecosystem. The Earth is so complicated. If you just think about, again, your stomach, you don't know everything that's going on in your stomach. You don't know all the microbes and what they're all doing. And then you magnify that times the size of the entire planet. It's really difficult to understand everything that's happening all at the same time. And then now we're adding unknown dynamics. We're adding a forcing that we haven't seen before in the form of climate change. So we're working really hard to forecast what the changes are, but I am not a fortune teller. So I'm not able to give you a specific date. Just like I probably wouldn't be able to give you a specific date when, something in your life is going to happen to you. I can't read the future. All we can do is we can look at the patterns and see the signs of what's going on the planet and make our best guesses as to when those things would change or could change based on the patterns that we understand.
But I come from business management, economics, and I have a tendency of oversimplifying things and trying to simplify things to understand it better. So we are talking about a real pressing problem. It's not, when we talk about the time scale, it's not something that can happen potentially in 400 years. It's a real pressing problem that should be solved in our lifetimes and not somewhere in the future.
A paper just came out in Nature saying that some researchers ran different models, and they believe that we will have 1.5 warming in the next 2 years, which will cause, again, more further instability of ecosystems. And that could push us to 2 degrees, which is the absolute worst that we've forecast within the next few decades by 2050. So we're talking about something that really needed to be taken care of yesterday.
No, yesterday. Good. 2 degrees doesn't sound really dangerous to me. What are the consequences of a 2 degrees increase in temperature on the planet?
Well, they could be catastrophic depending on the location, right? So we have not hit 1.5 degrees yet. We're already seeing a lot of snow that is gone in the Alps. We're seeing droughts across Europe. We're seeing flooding and very strong storms throughout the Americas. We're seeing significant loss of sea ice. We're seeing melting and thawing of permafrost and glaciers, like you said, and that all means potential sea level rise. So we're not even at 1.5 yet. And there are already this year or last year, $300 million in damages per region in the US. And then there were 30 million people who were affected in the US directly by climate disasters. So I'm just throwing all these numbers at you to basically try and help understand that things are already kind of serious. And we're asking for them to be more serious, more bad. And it seems to me that in my personal life, if things were already going badly, I would do everything I could to make it better, not to just continue making things worse.
You mentioned that we see a decrease in biodiversity. So far as my understanding goes, I mean, we need this biodiversity as a human race to live a healthy life so that we have enough to eat. When biodiversity is decreased and we see species going extinct, I mean, at the end of the value chain, nutrition-wise, is the human race. So is there a potential risk that we also have to face extinction of the human race if we continue on that path?
So I think that you're looking at this from a very economics perspective, which I value. There is more to biodiversity than the value chain, right? Like we are an intrinsic part of our ecosystem. Everything that you breathe, everything that you drink, like you said, everything that you eat, everything that you see is part of the biodiversity and the ecosystem. Think how lonely it would be if we woke up and there were no birds, just none.
Yeah.
Think how weird it would be if in the summer the leaves barely grew. We're talking about the potential loss of all of our friends and relations across scales who are plants and animals. I mean, this is much more serious than not having adequate resources. They also have intrinsic value, right? Everything on this planet has a value, and I think it's more than time for us to realize that as humans, that all of these things that we have evolved with have importance and they have value, regardless of what service we believe that they provide, because they provide much, much more to us than we probably understand.
Yeah, that's true. I couldn't agree more. Today, as I prepared for this recording, I was on your LinkedIn profile and I saw that there was a train accident in Ohio with the release of toxic chemicals. And also learned from doing the research that there is also a research out that links extreme weather events to the release and spread of toxic chemicals. Can you tell me a little bit more about this topic?
Sure. So a growing concern for me is the way that things are moving in the environment and all of the different human inputs. So Ohio is a great example. There are, to my knowledge, just under 10 chemicals that were either released or created because of the release, and many of them are extremely serious. Some of them were burned off by the remediation efforts, and when you burn some of them, they make different chemicals that go into the atmosphere. So we have this system where we are basically putting whatever we want into our near ecosystem, whether it's brominated flame retardants, which cover our sofas and cover our mattresses, whether it's unintentional dumping or release of these chemicals in Ohio, or whether it's things that we've stored in the permafrost and now they're going to thaw out. All of these are significant risks. And when we combine them, we're not even necessarily really sure what all the chemicals will do when they're combined. So it seems to me the absolute best thing to do is to stop putting all of these chemicals into the environment without thinking about where they're going to go, without thinking about how they could impact the local environment. And that's something that we've said in a bunch of different media, a bunch of different papers. We've got a couple Nature climate change papers about it. This is a very important and serious thing for us to consider. It's not just microplastics. It's also things that we can't see, chemicals that we can't see that really impact life on Earth.
Yeah, and we were good at putting that into the atmosphere, to the environment. What is your recommendation to governments? How can they better contain toxic chemicals during disasters and also during normal life?
Yeah, so I am not a politician, unfortunately, and can't really talk about policy. But as a scientist, I know that it's really important that things stay in their right place. So, I wouldn't necessarily fill a beaker full of a chemical and then drink it, because that's not the right place for that chemical. And it seems like it's important for us to think about that when we make our laws and we make our regulations for all chemicals.
You said that you're not a politician, but a scientist. Let's talk a little bit about, I think it's probably also one of your favorite topics, science communication. How important is that these days?
Well, I have been nothing but impressed by the younger generations who are really, really excited about learning about science, talking about science, helping each other understand science, helping people older than them understand science. And so I just want to be part of that community that's engaging with the world around us in new and interesting and different ways. It's also really, really important that we increase the diversity in science so that people of all different races, all different origins, all different genders can share their novel and breakthrough ideas to help all of humanity. And that's really the nature of science, to make it totally open, totally accessible, so that we get just the very best ideas on the planet that can help everything. And that's a huge part of why I do science communication, just to make it clear that everyone is welcome and all ideas are welcome. And that's the process of science.
Yeah, and it seems that you and your teams are doing an excellent job, a fantastic job. I mean, you got international recognition in the BBC, New York Times, GQ. And did I read it right? You also, in 2020, got a Guinness World Record in science communication.
Not in science communication, for climbing Mount Everest and taking samples. That was a different thing. Yes, we found the highest microplastics in the world. So quite a sad thing to have a Guinness World Record for, but that's what it was for, yes.
At the Mount Everest?
Yeah, on Mount Everest.
So basically plastic that was not brought there by someone who tried to climb the Mount Everest. It was microplastic that somehow, did you understand?
There are probably a variety of sources. Some of it is definitely from the gear, from the people climbing Mount Everest, but it's also been shown to be atmospherically moved. So there are microplastics in the atmosphere that come down through the rain and that can move in the wind as well.
I also learned today on your LinkedIn profile that you asked people for recommendations of a title of your new book. Can you tell me a little bit more about this book? What do you address with it?
So I'm working with Taylor and Francis, and the book will hopefully be out in 2024, talking about planning for climate change. So how should my generation, which is millennial, I'm an elder millennial, and younger generations understand and think about climate change in the way that it impacts their lives? How do they plan for it? Where should they live? What should they think about eating? Does everyone need to go vegan and go live in a cabin? That's not very reasonable. What are the other options? And so just trying to give people a way to think about climate change and the way that it could impact them, that's healthy and helpful.
Yeah, vegan. I'm a member of the Shaolin Temple, and it's they have a vegetarian lifestyle, and it's also a Buddhist temple. I think there is probably a lot of solution, not so much in Buddhism. I mean, there are different religions on the planet, and it is fine, but probably in the lifestyle. So it's not over-consuming, not overusing the resources of the planet. I also found when I researched your vita that you have a black belt. Is it also in martial arts?
Yes, I have a black belt in Kempo karate.
How is that? How was it? Are you still practicing?
Good. I actually moved away from my dojo, so I'm not actively practicing Kempo, but yes, I absolutely love the discipline and having fun with karate.
Yeah, that's true. That's true. I started with karate when I was 6-7 years old, and then switched to more Japanese style Bujinkan. And later in life, I learned that close to my house, the subsidiary of the Shaolin Temple opened, and I started training with the Shaolin monks. It's great. Doing some exercise.
That's amazing. Yeah, very impressive. Cool.
It's coincidentally, and I was once in the temple in 2014. I think there is a lot in Buddhist lifestyle. When we talk about the future of climate science, where do you see it evolving in the next 5 to 10 years?
Well, there's a lot of people who are moving into the earth and climate space, which is wonderful. There's people of all sectors, all disciplines, all backgrounds that are needed. We need communicators. We need people, like I said, who are taking action. We need researchers. We need thinkers. We need planners. We need artists. We need so many artists. There are all sorts of people who are moving into this field, and we need them all there. We all need to be thinking about climate change and the way that it impacts our industries, our lives, because it's going to, and it will be much, much better for us to think about it now than, as the hurricane hits, whether it's metaphorical or actual. I think that in the next few years, we're going to see an influx of more people, like I mentioned, but we're also potentially going to see more and more talent maturing for people who are just coming out of graduate school. And there is way more diversity, like I mentioned, in this field than there ever has been in the Western sciences in the past. And that is going to really benefit us. It's going to really benefit us to have people come from different backgrounds and have different stories in their lives and different ways of thinking, so that it can really make us more diverse, more ingenious, think of more ideas, have better brainstorming sessions. And I'm really looking forward to that. I'm also really looking forward to the integration of Indigenous knowledge. So Western science has for a long time really dominated this conversation and speak very, very loudly. But we have a bunch of people who are very, very good at science that looks different than Western science. It's not necessarily from the Enlightenment. It's from time immemorial, time much, much older than that. And I think that there's a huge drive and importance from those conversations that I'm looking forward to emerging even more strongly in the literature and just in the day-to-day media.
That's interesting. When I thought about climate change, I was thinking about policymakers, politicians, scientists, and the industry. And you mentioned other parties, for example, artists. Why, in your opinion, is it important to have artists in the conversations?
Oh, because artists are incredibly important to humans. What are humans good at that no other species or very few other species are good at? There are some birds that make just the most gorgeous nests. I get that. But humans have this incredible drive and dedication to creating all different kinds of art. It's how we speak to each other. It's how we motivate each other. There's a new series coming out I just saw on Apple Plus, I think it was, where a bunch of very important Hollywood stars have put their time towards thinking about what climate change will look like in the future, how it'll impact people. That's an amazing way for us to communicate with each other. And art is also the most important thing for driving me, right? I want to make sure that I've got art in my life so I have something to work towards and to consider as far as humans go. What makes humans special? I can go outside and see what makes birds and animals and plants special, but what makes humans special? And I would argue that one of the main things is art. And I think science is part of that, the fusion of art and science.
Yeah, that's true. That's true. It's great to hear that from you, that also art has a very important place in our society.
Yes, absolutely. Definitely.
When we think about the future in the last 5 minutes of our interview, and we would need to pick the 3 most important actions that we should take today to change the fate of the human race and the planet in terms of climate change. Which 3 actions would you recommend that should be emphasized?
It's hard to say just 3, but let's just do it from the top of my head. I would say the number 1 would probably be stop dumping carbon into the atmosphere. Probably number 2 would be to dedicate land space to wilderness or to Indigenous stewardship. So meaning that we don't develop things, we don't cut down forests and build apartment buildings, we don't turn a bunch of the Arctic into mines, which is a terrible idea that some people are suggesting. We preserve a huge amount of the Earth's surface, or like I mentioned, give it back to Indigenous stewardship. And then probably the third thing is just to make sure that everyone knows, speaking to friends, speaking to family members, speaking to all of our relations, to make sure that we are all in conversation about the reality of what's happening on the planet where we live, the only planet where we live, the only planet we have the capability to live on. We cannot move to Mars. We need to discuss with each other what's happening and what that means for us, in our daily lives, for our children, for our grandchildren, and for all other species' children and grandchildren.
So you don't trust in Elon Musk that we can build a second Earth on Mars?
I have no comment on Elon Musk.
Sorry. Taking the carbon out of the atmosphere, I always thought planting trees might be a way out. And you mentioned as the second measure that wilderness, that giving back or rebuilding the wilderness might be part of the solution. Can you explain it a little bit more in detail?
Sure. So it really depends on the regional ecosystem, and we are getting a little bit close to time, but there's a bunch of different articles and studies out there that show that not only trees, but lots and lots of different plant species uptake carbon. So it could be seaweed, it could be tundra, which is land with different plants on it, meadows. That's basically what a lot of plants eat. And so in order to have this regeneration, I guess, if you will, of the atmosphere, moving our planet back to a more stable state, it is going to be critically important to make sure that we preserve a huge amount of the plant species in a way that we haven't done in the last 100 years. It's also really important for the biodiversity crisis for obvious reasons. Everyone needs somewhere to live. That includes if you are a tree frog or if you are a human person.
So emphasizing this point that we need more trees, we need more wilderness towards politicians helps contributing to climate change. It's good to know. Kimberley, we have 2 minutes left. Is there anything that you would like to tell the audience that I didn't mention or didn't ask you in this podcast?
No, Christian, I just appreciate your time, and I hope that folks will be able to get some meaning from our conversation. And it's been really nice to chat with you today.
It was fantastic chatting with you. Thank you very much for your time and your great research and your great work and helping me and the audience understand the problem of climate change better and what we can do to change it. Thank you very much and have a great day.
Thanks, Christian. You too.
See you. Bye-bye.
Bye.